All right, let's dive into something that's happening all around you right now, but you probably never even think about it. We're talking about the invisible magic that connects all your local devices, your computer, your phone, that printer in the corner. How do they all talk to each other so flawlessly? Let's get into it. Seriously, have you ever just stopped to wonder about that? You hit print on your laptop and magically a document starts spitting out of your printer across the room. They're both just on the same Wi-Fi network. There's no cable connecting them. It's not going out to the internet and back. It's all happening right there in your house. So how in the world do they actually find each other?
Well, the answer lies in this really fundamental piece of how all networks work. You can think of it like an invisible traffic cop, standing in the middle of your living room, directing all the digital conversations happening between your gadgets. It's working right under your nose.
And that unsung hero is the data link layer. You'll also hear it called Layer 2, and its one and only job, its entire reason for existing, is local delivery. I mean, it couldn't care less about the internet. Its whole world is just your home or office network, and its mission is to get data from one device to another, right there, safe and sound.
Okay, so how does it actually pull this off? Let's break it down with a super simple analogy. Let's think about your local mail service. If you want to send a letter to your neighbor, you can't just write a message on some paper and throw it out the window, right? You need two things, an envelope and a specific address.
While in the world of networking, that digital envelope is called a frame. The data link layer's first job is to take all the raw data that your computer wants to send and neatly package it up inside one of these frames. It's basically organizing the data, getting it all sealed up, and ready for its quick trip across your local network.
But of course, an envelope is totally useless without an address on it, right? It's the same thing here. A frame is just a package of data. It needs to know exactly which device on your network it's supposed to go to.
And that is where the MAC address comes in. MAC stands for Media Access Control, and you can just think of it as the permanent physical street address for your device. It's this unique 48-bit number that is literally burned into the hardware, into the network card of your laptop or the Wi-Fi chip in your phone the second it's manufactured. It's permanent.
And this is the really cool part. Every single device in the world that can connect to a network has its own completely unique address, just like this one. Seriously, no two devices on the planet share the same MAC address. It's like a digital fingerprint. It's how your local network can tell your laptop from your printer or your smart TV from your phone. No confusion.
Okay, let's recap. We've got our data tucked inside a digital envelope, the frame, and that envelope has a very specific delivery address, the MAC address. So, what now? We need a local post office, something to actually sort the mail and get it to the right place.
In pretty much every modern network, that post office is a device called a network switch. If you've ever plugged an Ethernet cable into a box with a bunch of ports, that's a switch. And, there's one built right into that Wi-Fi router you have at home. Its entire job is to look at the destination MAC address on every single frame that comes through and send it only to the device it's meant for.
So how does it know where to send it? This is where the switch is actually pretty smart. As your devices start talking on the network, the switch is listening. It builds a little cheat sheet, a table just like this one, that keeps track of which MAC address is plugged into which physical port. So later, when a frame comes in addressed to the device on, say, port 2, the switch doesn't just shout it out to everyone on the network. Nope, it looks at its table and sends it directly and only to port 2. It's a private conversation, and that's a huge reason why our local networks are so fast and efficient.
Now, a good mail service isn't just about speed, right? It's also about reliability. You want to make sure the letter actually arrives and that it isn't ripped or damaged. And you definitely don't want the mail trucks crashing into each other. Well, the data link layer thinks about that stuff too.
First up, making sure the message arrives intact. How do you know the data didn't get scrambled along the way? Well, tucked inside every frame is a little something called a checksum. It's basically a special math problem. The sending computer does the calculation based on the data and puts the answer in the frame. When the receiving computer gets it, it does the exact same calculation on the data it received. If the answers match, great, the data's good. If they don't, it means something got corrupted, and that frame just gets tossed in the trash. It's a super important quality check.
Okay, next, we have to prevent chaos. You can't have all the devices talking at once. It would be a mess. So the data link layer sets some ground rules. For a wired network, an Ethernet connection, it uses something called collision detection. The rule is basically, listen before you talk. And if two devices accidentally talk at the same time, a collision, they both just stop, wait a random amount of time, and then try again. Now, Wi-Fi is a bit different, a little more
polite, you could say. It uses collision avoidance. It tries to prevent collisions from ever happening. Devices listen for a clear channel, and they'll even announce their intention to send data so others know to wait their turn. It's all about keeping the airwaves clear.
So I know this can sound a bit deep in the weeds and technical, but the crazy thing is you are using the data link layer constantly, every single day. Let's just pinpoint a few times you've probably used it today already.
That moment your phone connects to the Wi-Fi, bam, that's a Layer 2 connection being made. Plugging an Ethernet cable into your laptop for a stable connection? Yep, that's Layer 2. Wirelessly printing that document we talked about earlier, or sharing a file with someone in the same office. All of that, every single one of those actions is made possible by the frames, the MAC addresses, and the switches of the data link layer. It is truly the foundation of all local networking.
So, here's the bottom line. Without the data link layer, your local network would be absolute chaos. Just imagine a room full of people all trying to talk at once, but nobody has a name. That's what it would be like. Layer 2 is the thing that gives every device a name. That's the MAC address, and it provides the rules for who gets to talk and when. It turns all that potential chaos into orderly, efficient communication.
So we've established the data link layer is the absolute master of local delivery. It gets the job done perfectly within your home or office, but that leaves one giant question, doesn't it? If MAC addresses only work locally, how on earth does an email from your laptop get to a server on the other side of the planet? How does it leave your local neighborhood? Well, for that journey, we need to climb one rung up the networking ladder, to the network layer. And that's exactly what we'll break down in our next explainer.